and thank you for your interest in my poster titled Regression-Based Mass Univariate EEG Analyses Suggest No Word Frequency Effect in Processing of Regular Inflections. My name is David Abugaber, and I'm a PhD candidate with the Cognition of Second Language Acquisition Lab at the University of Illinois at Chicago. So, psycholinguistic models have competing accounts for how we process morphosyntactic inflections, like for instance the difference between eat versus eats. Single root models say that associative memory-based storage of surface forms is the sole mechanism for inflected form processing. By contrast, dual root models say that rule-governed composition is another possible mechanism, such that you don't need to access a stored representation of the word surface form to process the inflection. One way to test these competing accounts is to see whether the frequency of a word surface form affects grammatical processing. The single root model would say yes, and the dual root model would say no. To our knowledge, only one study has investigated this question using EEG, which can detect effects that can't be detected with behavioral measures alone. In this study, Allen and colleagues found no interaction of a word's grammaticality status and the word's frequency in the context of a sentence reading task. We extend Allen and colleagues by using two different grammatical forms and by using an analysis method that increases statistical power by retaining information from each time point in each trial. Now, our research question is, does word frequency interact with EEG responses to morphosyntactic violations on regular forms? We had 56 native English speaker participants. Each of them read sentences that could either have a grammaticality violation between a subject and a verb, as in, for instance, the authors publish versus the authors publishes, or they'd read a sentence that could have a grammaticality violation between an article and a noun, like a cookie versus a cookies. For each critical word in each sentence, we extracted the frequency in the English language overall based on the British National Corpus. This panel contains more information about our EEG pre-processing steps. When we take a traditional approach that uses averaging within time windows, like in Allen and colleagues, we reproduce their findings. For both the subject, verb, and the noun phrase conditions, we get a P600 effect for grammaticality violations, an N400 style effect for words with lower frequency, but no significant interaction of grammaticality and frequency. However, there are two limits to this approach. First, doing a binary low versus high frequency split instead of treating frequency as a continuous variable can reduce statistical power, increasing type 2 error. Second, averaging the amplitude within the time window can reduce statistical power if the time windows don't correspond to the timing of the effect. But choosing a time window based on visual inspection can lead to false positives, increasing type 1 error. So, one way to address these issues is by implementing mass univariate analyses. First, by using linear regression that treats frequency as a continuous variable, we improve our statistical power. Second, by testing each time point and controlling for false positives with cluster-based permutation testing, we avoid issues with averaging amplitudes and time windows. Our regression model at each time point included grammaticality, log transformed frequency, and the interaction of the grammaticality and frequency, as well as control variables word length in letters, word position in sentence, and sentence position in the experiment. Turning to our results, these figures show, for each of the subject, verb, and noun phrase conditions, which effects were significant at which points in the time trial. For both conditions, we found significant clusters for grammaticality starting at around 500 milliseconds. We also found significant effects for frequency at around 400 milliseconds. However, critically for our purposes, there was no significant interaction of grammaticality by frequency. So, our findings reproduce Allen and colleagues. We found main effects for grammaticality and main effects for frequency, but no interaction of grammaticality by frequency. This supports the dual roots model's account of rule-governed composition instead of stored representations of surface forms in processing of these two morphosyntactic inflections. More broadly, our approach illustrates how mass univariate analyses can be implemented to retain per trial and per time sample information in EEG analyses.